Okay, let's see if you got them right. So the symbol for heat is Q, oddly enough. You might wonder why didn't they use H. That'll show up a little bit later in the course. And the unit is the joule. Sometimes you might see the kilojoule in the same way that if you had meters, you might see kilometers, right, or kilometers. It's possible to see that, but for right now, we don't need to worry about that. And then temperature, the symbol's just a big T, and we're going to use degrees Celsius. That's the one where water freezes at 0 and boils at 100 degrees Celsius. What we're not going to use is Fahrenheit, which is probably what most of us are more familiar with. For instance, a hot day in Celsius is like, 40 degrees Celsius, not 100 degrees Fahrenheit, right? But we're not going to use that. And if you've ever heard of the unit called the Kelvin, we're not going to use that much either. It's pretty much going to be degrees Celsius. And then mass, since we know the amount of material matters, mass we've already used earlier in the course. Remember when we had a balance or a scale? That's the gram is the unit, and we're just going to use an M for mass. I know it might be a little confusing because we use M for meters, but that's a unit, not a symbol. So we're just going to use M for mass. All right, now we have our variables. Let's go see if we can flush this equation out more and see if we can figure out how we're going to do our calculations. So the actual equation is going to appear down here in the box in a second, but I want us to think through what we know. We know that there is a relationship between heat and temperature, but they are not the same thing. I should not be saying heat equals temperature. They are not the same thing. For one thing, we've learned that as we add heat to each beaker, if we have the same amount of heat, it affects the temperature differently. So it's not really that heat is related to temperature. Heat is related to change in temperature. And that's really important because we're going to use the symbol delta for change. So it's delta T, change in temperature. So like we might say the final temperature minus the initial temperature, well, that's the change in temperature. So in our formula, we're not going to have T, we're going to have delta T, which means change in temperature, like final minus initial. The other thing we know is that heat is not directly related to change in temperature. If it was, these two would have both increased their temperature by the same amount. They would both read the same thing. But they didn't. It had to do with the amount of material. And that's where the mass comes in. Somewhere in here, we're going to have the mass. So the formula, what it's going to look like is this. And that's what I want you to get in your notes, because you're going to use it a lot today and for the rest of the unit. So we know that Q is heat, M is mass, C we haven't talked about yet. We're going to get to that in a second. And this is change in temperature. This is the final temperature minus the initial temperature. So let's talk about C. What is that? Well, what C is C is the heat capacity of water. It's a constant. It's a lot like pi. It's a number that's 4.184, and I want you to write that down as well because it will always, C will always be the number 4.184. A lot like pi is 3.14. The heat capacity of water is 4.184. Now I told you today we're only going to look at water. We're not going to look at metals or other things, but as you can imagine, that number is going to be different for other things like metals. All right, so let's do an example together. Let's look at beaker A. In beaker A, I notice my picture on the left is not as good as my picture on the right. But in beaker A, we heated up the water, and I want to know how much heat did it take to get the temperature to go from 17.6 degrees to 53.1 degrees. That was a change in temperature. So when we calculate change in temperature, that will go right here, we're going to do the final temperature minus the initial temperature. That's how we're going to get delta T. C, no problem. We know what C is. It's 4.184. It's that constant that relates to water. It's the heat capacity. But we're also going to need the mass. So the mass, if we come up here, I didn't have a scale or a balance at home, but I do know this, that there's a little over 200 milliliters of water here. I might say that that's 200 and, I don't know, let's say 205 milliliters. Well, since water has a density of 1 gram per milliliter, that's about 205 grams. So I'm going to use 205 grams. We're going to assume milliliters is the same as grams because the density of water is 1. All right, so we know the amount of water we had. We know the change in temperature. It went from 17.6 to 53 degrees. And we know the specific heat of water. Let's set up our formula. Okay, well, if I want to know how much heat it took to do that, I have 205 grams. That's going to be my mass. My specific heat capacity of water is 4.184 joules per gram degrees Celsius. Boy, that's a unit, isn't it? And then my delta T, I'm going to put in right there. Well, you remember, delta T is the final temperature minus the initial. The final temperature was 53.1 degrees minus the initial temperature was 17 degrees. That's the change that we saw. So I do 53 minus 17. And I get 35.5 degrees Celsius. I'm probably going to do that subtraction first, right? So I subtracted those two and that's what I got. Now I can multiply it times 4.184, so that came down from up there, and this is 205 grams, and if I multiply all those together, I can get Q. And when I do that, what I get is 30,449, and we got to decide on a unit. It's heat, and do you remember what the unit for heat is? It's the joule, right? So I'm going to put a joule down here. But if we look up here, we can cancel our Celsius with our Celsius, our grams with our grams, and yep, we would have been left with joules. So it was 30,000 joules of energy to get the heat, the water, to go from 17 degrees to 53 degrees. Now, before we go on to another example problem, I want you to come down here and plug these values in your calculator and make sure that you get the same thing so that you know that you're calculating things correctly. Pause the video and do that. So let's look at another example. Now, if you're saying, I think I know how this works, I'm going to ask you to work ahead of us in just a moment. So we've got beaker C and beaker D here. I noticed I actually left videos in here.
Just like last time, we're going to speed it up so that you don't have to wait. And I want you to go back.
All right, so you can hear all of that dialogue that's going on there. But we're going to let these things change their temperature. And you remember they started up here around 17 or 18 degrees and they got colder because we added ice to them. Now we're going to choose one beaker. Let's choose beaker C. Why? Well, I guess partially because we haven't done the little one yet, but also because I think it's easier to see the temperatures. So there's beaker C, there's beaker C. What I want you to do is you can see beaker C went from 18.2 degrees, I think that's 18.2 degrees Celsius, to 3.5 degrees Celsius. You can see about how much water's in there. I'd say a little over 50 milliliters. And I want you to use those values and calculate how much heat was lost by the water. So pause the video here and do that.